Welcome back to the Datarekha audio guide. I'm Diya.
And I'm Arjun. Today, the idea that turns how similar do these two sentences mean into a question you can answer with geometry.
So, what actually is an embedding? People throw the word around like everyone knows.
An embedding is just a list of numbers that represents a piece of text by its meaning. The magic is what by its meaning buys you. I love dogs, and I adore puppies end up as points sitting right next to each other. I love dogs, and Python is a typed language end up far apart. Once text becomes points in space, everything else, search, clustering, recommendation, is geometry.
Paint the picture for me. Where do these points live?
Imagine a flat plane. Put cat near kitten and far from bicycle. Put dog near puppy, but also fairly near cat, because both are pets. Put Python far from all the animals, but right next to Java, because they're both languages. That arrangement, where position encodes meaning, is a 2D embedding space.
And real models obviously aren't 2D, or you wouldn't need the fancy math.
Right. Real embedding models output hundreds to thousands of dimensions, typically 384, 768, 1024, 1536, even 3072. You can't draw it, but the geometry is identical. Neighbors mean similar things. Distant points don't.
Okay, so I've got two vectors. How do I actually measure close? Is there one right ruler?
There are three common ones, and the differences matter. Cosine similarity measures the angle between two vectors. It ranges from -1 to 1, and crucially, it ignores magnitude. Only direction counts. Euclidean is the straight line distance, the everyday ruler, but it's sensitive to magnitude. And dot product is the cheapest. Just multiply matching numbers and add them up.
Why would I ever ignore magnitude? Throwing away information feels wrong.
Because for meaning, direction is the meaning. Take a vector and double every number. Same direction, twice as long. Cosine says those two are identical because they're about the same thing. Euclidean says they're far apart, fooled by the length. For semantic search, that length difference is usually noise. So cosine is the sensible default.
Here's something I bet trips people up. You said dot product is fastest, but cosine is the one that ignores magnitude. Can I get both somehow?
You can. And this is the trick the whole industry leans on. If your vectors are already unit length, normalized to length 1, then cosine similarity equals the dot product. Exactly. No division, no square roots. So the major providers, OpenAI, Cohere, Voyage, return normalized vectors by default, and vector databases index them and just use dot product internally for speed. You get cosine's meaning at dot product's cost.
So the honest answer to which metric should I use is almost always cosine.
Almost always cosine. The APIs return normalized vectors, the databases default to cosine or dot. Every tutorial uses it. Pick something else only if you have a specific reason and you've actually measured a difference on your own data.
Now these things are huge. 3,000 numbers each. Do I really have to store all of that?
Great instinct and no. Most 2026 models are trained with something called Matryoshka representation learning, like the nesting dolls. They pack the most important information into the very first dimensions. So you can chop a 3072 dim vector down to 512 or even 256 and keep around 93 to 95% of your retrieval quality. A fraction of the storage, a faster search. The common pattern is store the short vectors, then re-rank just the top hits with the full-length ones.
And once everything's a point, clustering basically comes for free, doesn't it?
Exactly. Similar texts physically clump together. So you point an algorithm like k-means at them, and it finds the groups on its own. Give it a pile of sentences, some about coding and some about fitness, and it cleanly splits them into two clusters without ever being told the topics. The geometry does the work, and when you flatten the high dimensions down to 2D to actually look, that's where TSNE beats PCA, because it's much better at keeping local clusters visibly separate.
Let me push on the limits because this all sounds a little too clean. Where does the geometry lie to you?
Two traps worth naming. Short texts embed badly. Yes and no can land close together because they're both tiny, so never embed single tokens. And domain jargon fools a general model. Trained on the open web, it may not tell long position from short position in finance. But the big one, the one that bites people in production, is this: embeddings model similarity, not truth.
Oh, so the capital of France is Paris and the capital of France is London would land almost on top of each other.
Nearly identical embeddings. The embedder knows they're about the same topic. It has no idea which one is correct. That's simply not its job. And that's the exact reason Rig retrieves with embeddings, but then has an LLM read the retrieved text. The embedder finds what's relevant. The model decides what's true.
So the one sentence to keep
An embedding turns meaning into a location and similarity into distance. But distance is about the same topic. Never that's the right answer. Use it to find things, not to judge them.
geometry for meaning and LLM for truth. That's the Datarekha audio guide. See you in the next one.